So I've been thinking about how to, I think about customization of LLMs and the fact that we've released a whole bunch of customization options for LLMs at reInvent. And it got me thinking, how big are LLMs? Are they expensive? Can everyone afford to run their own LLM? How do we think about cost? Wouldn't it be very expensive if everybody ran their own version of ChatGPT potentially? So this is an effort to understand the cost of LLMs and then what options we have for customizing them. So I'm not in this calculation. I'm not going to include things like training costs, because we're going to imagine that we're using a Llama 4.1 model. That's an open source model, open source weights. And so you don't need to train them because that's already been done. You also don't need to, or in this case, we're not going to worry about things like software engineers and other software in your ecosystem that you might need to buy or you would need to buy. But for the purposes of this, we're going to assume that doesn't exist either. And we're going to assume that we are starting a company called AWS, Abalone Wild Services. And you're going to invest in GPU hardware that's going to run an LLM. And you're going to create a service called Bedrose. And then you're going to sell that via an API to your users. Now, what we're going to do for the LLM is we're going to use Llama 4.1. So that's an open source model, has maximum of different versions, of course, but the maximum is a 405 billion parameter model. 405,000 million, 10 million, 100 million. Billion. 405,000 billion parameters. So when they train these things, they train them at various floating point numbers. Or by that I mean each one of these 405 billion parameters need to be stored in memory when the model is loaded. So if you can imagine, you could use 4 bytes per parameter. Now remember, a parameter is a bias or a weight. It's basically a number, right? So it looks 0.1, 2, 3, 4, 6, 9, 4, 6, 7, 6, 7. And that gets stored in a frame, if you like. So it could be 4-bit, 32-bit model. You could use a 16-bit model. You could use an 8-bit model or a 4-bit model. And I think you can even go lower than that. But you're going to run a 405 billion parameter model, and you can run it at 16-bit. Now, the reason you're going to do that is because 16-bit or 2 bytes per parameter plus a bit of extra gives you about 1 terabyte. 1 terabyte. That's how much memory you need to run this model. So what sort of hardware could you run? How do you get 1 terabyte of GPU memory? So the way I like to think about it is, just imagine you have a rack in a data center. It's about 6 feet tall, or 42 rack units. You could buy various combinations of hardware, but the one we're going to talk about is the NVIDIA, because why not? DGX H100, which is 8 H100s bonded together. And you need a little bit of networking equipment as well. But this one here is only 8 RU. Okay? 8 RU, and it comes with 640 gigabytes of RAM. Well, 640 gigabytes of memory for the GPU. So you can't run a full 405 billion parameter 16-bit quantized model. You need to run the 8-bit one, which is about 500 gigabytes. Now that's fine. It's still a very big model. It's still a very smart model. It will just be more coarse-grained than fine-grained is basically the way to think about that. You're still storing very long floating point numbers as parameters. So what does a device like this cost? Well, it costs about let's say to the average guy on the street, 350,000. But given we are AWS, Abalone Web Services, and we're buying in bulk, let's say we get it for 100,000. So we can buy this hardware at 100,000. We can plonk one model onto it, and then we can. So the DGX H100 as well has not just GPUs, but it's got your GPUs, but it's also got CPUs. So you could theoretically run your entire service off this one box. You probably wouldn't. You'd need extra networking equipment and, of course, a whole bunch of other things. But let's just say you're just looking at this in isolation. Now, you want to sell. This thing generates tokens. So we want to know how many tokens it can generate, and then we need to think about how much we charge our users per token. So the theoretical maximum of something like this is 19,000 tokens per second. $19,000 tokens per second, theoretically. But we probably can't get that. Let's be super conservative and say that we can get 500 tokens per second. 500 tokens per second. There are roughly 2.5 million seconds in a month. So you could generate, so if we times that by 2.5 million seconds, you could roughly generate per month 1.3 billion tokens. Now, if you want to work out how much you should charge per token, you could look at a popular cloud provider like Amazon Web Services, and you'll see on their website that they are selling the 405 billion parameter model. They don't say the quantization level, but probably assume it's 8-bit, maybe 4-bit. Let's assume 8-bit. They're selling that for $3 per million tokens. $3 per million tokens. So if you are generating 500 tokens per second in this case here, and you're charging $3 million per tokens, calculation ends up being about $4,000 a month. $4,000 per month. Now you bought that thing for 100,000, so it'll take you 25 months to get that payback. But if you're smart and you hire people that know how to optimize these devices, you can increase that 500 to something like 5,000 potentially, and then that drops, well, that increases, but that time to payback drops considerably. You could potentially get payback within the year or less. So it's definitely a lucrative business from that perspective. So what about taking this model and copying it, if you like? So if we think about the model itself, and we're going to draw the model like a layer cake. We're going to do 6 layers. Now, in reality, there could be many more, but ultimately your text or your prompt goes into the first layer, and then you get tokens out. Tokens, of course, translate directly to words. Simplification, but ultimately that's the way to think about it. Now, in each layer, you've got, when we talk about 405 billion parameters, we're talking about the weights within the neurons of each level, or each layer, I should say. Of course, this is drastically simplified. So you got the weights. So each of these, this guy over here might be 0.843667, blah, 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 blah. And this guy might be something, this one might be, minus 0.246101. And then in between them, you've got biases. So you can imagine they're all connected to each other. And so each one of these lines, if you like, has a number as well. So that could be 0.163432. Whatever the case is, all of these parameters, if you like, are frozen in this model. All right. So once the end of the training, when it's released, in this case it's Llama, so it's released to the public, you get to see all of these weights if you like, but you get the model as is. All right. And so if you want to change what comes out of here, if you want to make it speak like a pirate, or if you're a financial institution and you want bank, the word bank, to more likely be referenced as or used as a financial institution rather than a riverbank, as an example, then you can ask the model to do that with your prompt. And you can do that through RAG, you can do that through providing examples, you can do that through just using very instructive language, like you must refer to bank as a financial institution, etc. But really, once your prompt is passed through the model, you don't have full control over how the model sees that, and so you may get some inconsistencies in the answers that you get back. So you can, if you like, given this is open source, you can take this entire model and you could copy it over to a new, fully independent copy of the model. And so yes, you would need more hardware to run that. And then you could take this as a starting point, and then you could start to train or retrain this model based on your own training data. And so this, using this example here, let's say you trained it and the only thing that changed was this neuron here. The weight of that neuron might end up being 0.96367, etc., and everything else might stay the same. Unlikely. Everything would, or most weights in the model would adjust as you train it. So if you provided examples of financial documents as an example, it would then learn to skew probabilistically towards the word bank being in reference to a financial institution. So that's one way of doing it. But as you can imagine, that's 500 in the case of the 8-bit quantized model, that's 500 gigabytes. So you have to find 500 gigabytes of GPU RAM to run that independently. That's not cheap. So what you can do is something called an adapter model, which allows you to take a base model. And so you can do this, say, with AWS Bedrock. You can, AWS SageMaker, I should say. You can have another model, very lightweight model, that sits beside this model and interjects itself, if you like, at various parts within the layers. Let's say you got 3 there. So whereas this model is 500 gigabytes, this thing here might only be 10 gigabytes. And so what it does, it's like an augmentation of that particular layer, right? So when the network is pulsed, i.e., when these are activated, this layer not only pushes to there, but it will also push to here. And then this and this will be taken into consideration. And those will be the inputs to the next layer. I'm simplifying it here, of course, because there needs to be a matrix where there's connectivity between these. But ultimately, what you can imagine is that you can provide a personality, if you like, or additional nudges in a certain direction at certain parts of the network. So this part of the network, or this layer of the network, might be the one that determines that the word bank is more likely to be a verb rather than a noun, or vice versa. This one might be about the some other quality or attribute of that word in relationship to the other words. And so you can have these adapters and you can swap them in and out using the same large base model but a whole range of adapters depending on the conversation that you're having with the user. So you've got sort of three ways, I guess. The first is just manipulation of the incoming tokens, so system prompting. You've got this adapter model, which is like a lightweight customization. You've got full retraining. Sorry, you've got frozen weights, which you then retrain, and so you're running another copy of the model. That's more expensive again. And then you've got the option to go and train your own model from scratch, which is what the new Nova Forge offering from AWS is going to be about. It may not be right at the beginning, but it's very early in the training stage of a foundational model, so that you can have the most influence over and consistency over what comes out of it. There you go.